Well, it's a pleasure, Jeremy, to have you here. Yeah, I think most people already know you. Yeah, as a senior lecturer from Glasgow University. And well, there's loads of stuff on your webpage, as I see. So I don't really want to repeat it all, because the nice thing is you just need to put Jeremy Singer into Google and immediately you get his webpage here as first suggestion, with loads of work there and quite a wide range of areas related to programming languages. And it's great to hear that you think that Haskell is a nice programming language. We heard that last time. But well, today you want to tell us a bit more about data science and how people there well, in kind of do their programming. So well, up to you.
Brilliant. Thanks, Olaf. And good afternoon, everybody. It's virtually, at least. And I look forward to the day when I'll be able to visit you physically as well. Thanks for having me today. I want to talk to you about work which a final year undergraduate student and I were doing over the last few months. So as you might expect with a typical student project, there are still one or two holes in this, but I'm hoping to fill those in perhaps over the next few months in the summer. This talk's called Metaprogramming in Jupyter Notebooks. And first of all, we need to think about what Jupyter is, although I guess most of you use or know about Jupyter. The project's been around for the last 5 or 6 years, perhaps, and really has become very popular. Before that, it was the IPython project, and the idea is this is a very interactive REPL-based way of evaluating programs. Originally Python programs. Jupyter actually is a portmanteau of Julia, Python, and R. But now there are, I think, almost 100 different kernels of mainstream languages which will run inside Project Jupyter. So to think about how this programming language, I want you to consider the evolution in developer tooling. Some of us, myself included, I must confess, are still stuck in the 70s and 80s, and we write in text editors. Yay! So this is an Emacs editor here for my sins. I use Emacs normally, and this is a, I suppose, a terminal interactive way of developing code. In subsequent decades, people moved on to more GUI-based interactive ways of developing programs. This is perhaps VB6, I think, from Microsoft. And the idea was that you were developing graphical applications, so you'd want to develop them using a graphical toolkit, an integrated development environment like Visual Basic. But now, in modern times, everybody's stuck inside their web browsers. So the idea of Jupyter is that you'll develop code inside the same browser environment that you use for everything else, you know, writing your documents in Google Docs and talking to your friends in Facebook and going to seminars in Microsoft Teams. So do everything in the browser. That's the idea of Jupyter. You can code inside your browser as well. Jupyter Notebooks, which are these project environments for coding, are becoming increasingly popular. So there are over 1 million notebooks on GitHub for open source code projects. And as you can see, this exponential curve hasn't started flattening yet. The architecture of the Jupyter system is very much distributed. So the user is interacting via a browser in some kind of client device, and they're sending messages over HTTP to a server. Now, very often this server is really physically co-located on the same system as the client, but it could be, you know, half a world away, and this server just presents a web interface to the client. The server has some kind of persistent layer, so you can store notebooks. as files, typically JSON files. And also, the server interacts with a programming language kernel. In this context, kernel just means interpreter or evaluator, really. Normally, these are separate processors, but running on the same system using some kind of messaging protocol like 0MQ or something like that. What happens is the user types in fragments of source code, which gets sent through the server to the programming language kernel, which builds up in this read eval print loop style way a set of state, and then sends back output or values or perhaps even graphical output to the server, which relays them back to the client. So here's a UML sequence diagram. Here's a user clicking to execute a code cell in which they've typed in some data. Here is our browser, which sends over WebSockets or whatever some kind of message to the server, which could be a physically different device, which then sends the code all stripped down. So you've just got the Python code left to the kernel, which is effectively our stateful Python interpreter, which executes the code, then returns the value, if any, or the side effects of the output back to the server, which then replies to the browser, which then visualizes the output for the user. Notebooks are very popular coding environments. So I say here that novices like notebooks. We run a number of massive open online courses on the FutureLearn platform, a bit like you do as well, I think, with Simon's Erlang course and so on. And one of our courses is called Teaching Data Science. This is a course that's not really for computer scientists. It's for secondary school teachers, non-computing specialists, and it's giving them an introduction to data science in Python. And we use a notebook environment for that, not Jupyter, something slightly more cut down and simplified, but we use that for our novices here, and they really do like it. Look, okay, there's only 5 reviews there, but we've got 5 stars for our teaching data science, and they are very complimentary about the environment there. Scientists like notebooks too. So this is an article from Nature 2 or 3 years ago, and look at this. Jupyter is data scientist's computational notebook of choice. And the idea is that in this drive for open and cooperative science, a tool like Jupyter that allows people to share not only results, but also the analysis behind those results is a very popular way of communicating data science. So just thinking briefly about where notebooks come from, and this might be a slightly revisionist history of notebooks, but I'm going to claim that we can get inspiration from Donald Knuth and his notion of literate programming, the idea that, you know, code should be accompanied by high quality commentary interspersed with that code that somehow turned the whole thing into a beautiful document which can be read both by humans and computers reading different parts of it and so on. Stephen Wolfram, my middle mugshot here, and the Mathematica system was very much an early version of notebooks, perhaps not so popular because it was a proprietary tool aimed at experts, I suppose, but it did have that notion of interaction within the source code to produce user outputs interspersed with the code. And then Jimmy Wales is on the right-hand side there, the originator of Wikipedia. And I think here I'd like to draw on the idea of community-generated knowledge and that idea of the democratization of information for Wikipedia and code for the Jupyter system. So we were talking before about how students today like Stack Overflow. Students today like these things as well, copy, paste coding, which is very much facilitated in the Jupyter system. You have these little fragments, these little snippets of code, which you can, you know, copy from one box to another and from one notebook to another very easily. Also, the idea of bring your own device, you effectively just need something with a web browser. That could be your smart fridge, just as much as your, gaming laptop, and you can code on such a device. So this is an example of the structure of notebooks here. A notebook is really a linear sequence of cells. Unlike a spreadsheet, which is a two-dimensional grid of cells, notebooks very much are just a sort of cascade of linear cells. Cells can contain markdown, which is rendered in some kind of rich text format like this here. Cells might contain source code, and you specify the language in which that source code appears, and its syntax highlighted appropriately. And then cells, this code can be edited, and then you can invoke the cell, which will produce output. In this case here, the output is a graphical pie chart, which comes from matplotlib here. There's additional metadata contained in the notebook as well, such as the order in which cells are evaluated and the number of times they've been evaluated and so on, and other metadata too, which can be retrieved. So rather than code living in files, which is, I suppose, the paradigm we're used to, now code lives in little boxes, and little boxes are part of notebooks, which are themselves persistent JSON files. So notebooks do have some well-known problems. And if you want to hear an eloquent exposition of these problems, I recommend checking out this talk on YouTube. You just have to search for "I Don't Like Notebooks" by Joel Grue, and you can. He bravely presented it at the annual Jupyter convention, which was a bunch of notebook enthusiasts, and he told them all the problems, many of which were to do with user interfaces, but some to do with the underlying model of code execution. You can execute cells in a non-linear order. I've said there's a linear cascade. You can start at the bottom and go up to the top, and cells can be executed in a different way from which they appear and so on. And you get problems with persistent state that sometimes disappears from the notebook but is still held in the interpreter and so on. It's quite a confusing execution paradigm, certainly for beginners. Last year, I wrote a rather moaning, grumbling paper on why notebooks make me miserable, and this was a splash onward essay last year, so you could check that out perhaps. The most interesting problem I found, and the one I really wanted to spend some more time thinking about and working on, was this: notebooks don't allow introspection. So it's not possible within a notebook to find out anything about the structure of that notebook, or indeed to modify the notebook programmatically. So I wanted to be able to do Jupyter Notebook reflection, and that wasn't afforded by the existing APIs or interfaces. So just a minute, what is reflection? I probably don't need to tell you this, but what have I got here? The ability of a program to observe, reason about, and modify its own structure and behavior. So there's something about the sort of the layout of the program, and also something about the runtime execution of the program. Reflection is facilitated by reification, this idea that you can somehow encode the program structure and state as data, which you can then traverse and modify through the program. So there are lots of powerful programming languages that do offer reflective features, some of which you may be fans of. Here's some Java reflection here. So what we're doing here, printing out methods which we get hold of our current class, then get hold of the methods in the class as the method array, and then we can iterate over the methods array, and we can get the name of the method. We could invoke the method as well programmatically if we wanted to. So Java has a rich reflection API. And people do want to reflect in Jupyter notebooks. So here is a still open issue on the Jupyter GitHub repository. This is issue number 3101, and it's been open for the last 4 years. Okay, and it says, is it possible to access notebook elements from code inside that notebook? Okay, and there's lots of answers, but no satisfactory solution to W.S. Tom V's question here. So you might be scratching your head and thinking, well, why would I want to do introspection in a live notebook? Okay, and I'm going to suggest a few possible use cases here. I'm building up a nice catalogue of justifications for why you'd want to do notebook reflection. So if you've got any ideas, do let me know, and we can add them to this catalogue of reflective examples here. So one possibility is that you might want to generate a table of contents at the start of your notebook. And at the moment, you can't do that automatically while the notebook is running. You could do it by, I suppose, opening the JSON file of a notebook inside a non-running notebook, and then trawl through it and find the different fields and so on, and then generate your table of contents there and rewrite it to the JSON file. But then you'd need to reload that notebook into memory again, and you'd trash all your existing state and so on. So a dynamic table of contents is one possibility. I like the second use case here, a dynamic commentary on experimental results. So the idea here is that your notebook becomes a live scientific paper, and then you can programmatically look at your data and say, we have proved or disproved our hypothesis. So, you know, you can generate your conclusions programmatically from your data, perhaps. There's certainly a lot of interest in live executable papers and technical reports and so on. And I think to be able to provide that affordance inside Jupyter would be a powerful thing. From a more pedagogical point of view, you might want to use your notebooks for programming language learners, perhaps first-year undergraduates. I don't know what you teach your first-year undergraduates. We teach them Python, and we do use notebooks, but they are quite clunky. And it's not possible if the user makes a little mistake or has some kind of conceptual difficulty. It's not possible to be able to tailor the notebook structure or responses to the student directly within a live notebook that's running. Yeah, and then somebody else suggested this to me. I was talking to some colleagues at Edinburgh, and they were saying, yes, maybe you want your notebook to load and then reorganize itself and maybe delete parts of itself, some kind of notebook virus that has, you know, destructive side effects once it's running. Well, I suppose that is a use case, but maybe not a particularly helpful one.
Is that, Jeremy, can I add a sort of reflective thought on here?
Please do, yeah.
This may be kind of contrary to the state-based model that's at play in say, most of the notebooks that I'm aware of, but is there kind of like revisions or temporal aspect that you could get with reflection to be able to sort of say, oh, it's this version of this function? You know, if you had multiple definitions of the same function or multiple definitions of the same piece of data, which have the same name, but you in a piece of code want to refer to the different versions of them.
That's really nice.
But I think that doesn't interact well with the normal state model that's here, though.
Yes. So you're right. The namespace would just overwrite previous versions in the existing kernel model. So just talking about versioning, I think there are several weaknesses about versioning in notebooks. I mean, even just source code versioning, the kind of thing that we're used to with Git and so on, is not well supported in notebooks because these things have so much extra metadata encoded in the textual fields that, you know, version control becomes a little bit messy as well. But you're talking about having versions of perhaps data structures or functions in a system. I think that's certainly something that we could explore. I don't think the system I'm going to demo to you today, well, it definitely doesn't support that, but I think it might be possible to, have f at 2 and f at 3 and so on, and be able to, store, I suppose, a stack of versions of different data structures, perhaps. Yeah, thanks. That's a nice thought. Yeah,
that's right. I feel like Sam Aaron of Sonic Pi fame would perhaps have something to say about this, because in the live programming setting he has, there is some kind of idea about because you're doing dynamic code update, and he has been at various points looking at the temporal versioning of functions and things, and being able to address them and things like that. But he already has to do some clever things with state and versioning.
Yeah.
Another thing. Sorry.
Go for it. Sorry.
I was going to say another thing you might want to have is public and private versions of a notebook. I mean, if it's like some of the things I do, if you look at some of my papers, they're riddled with commented out sections, because I just use a plain old editor. And these commented out sections are quite useful for me, as I'm trying to think what I'm doing and how to express myself, and putting down ideas rather, well, should we do it this way? Which isn't what I want in the file, is useful to me and whoever I'm collaborating with at the time.
That's nice. Hello, Richard. Lovely to see you, by the way. I think you're suggesting a kind of accordion-style collapsible notebook where you can make things appear or disappear depending on who's reading. Is that right?
Well, possibly, or possibly like your virus point. Oh,
I see.
This notebook has been loaded by Jeremy. I will take out all the rude comments about Jeremy I put in there.
Yes. Okay. Yes. So there's, I suppose, different views on the underlying notebook, and we can support that through this reflective API. Yeah. Okay. Thanks. That's nice as well. Good. I'll carry on with my next slide here. Thank you. Do feel free to interrupt.
One more thing, perhaps. I was muted. Sorry. The one thing I'm looking forward to is so you mentioned the outline. The one thing I'm missing from the notebooks or notebook style like stuff I'm using, it's R markup, which is not strictly a Jupyter notebook. But what I can't do is iterate over the chunks. And often I want to parameterize part of my notebook and have a part where I essentially loop over multiple chunks.
Thanks. That's interesting. Yeah, I'm scribbling all these things down here. Hope you don't mind. I'm going to add these to my catalogue of interesting things to do with Jupyter Notebook reflection. Thank you. Right. Good. So, note to self, setup demo. I did that while I was just talking to you there, Stefan. Haha, good. So I think there are some challenges with implementing reflection in the Jupyter system. One is the distributed nature of notebook execution. You are looking at the program and the state inside your browser, but then on the server, state is being accumulated, and sometimes those two things can become inconsistent in some sense. I suppose that's to do with things like the versioning or lack of versioning that we spoke about just before, Dominic, and possibly, a confusion about where the state actually is. I mean, really, the state is being accumulated in the kernel on the server, and we just have a sort of remote understanding of that state. Jupyter is very much a polyglot system. We've got JavaScript running client side, and Python running server side, and maybe not only Python, there could be other languages as well, which complicate the reflective API. And then Jupyter really is a message passing system, and messages strictly sequenced, and you can't interrupt one message to put in another message. We'll see why that's important when we come to understanding state update. Okay, so I sketched out a draft API for notebook reflection with my student, and we came up with these sort of structural notebook calls here, which will allow us to change the cells in the notebook to get hold of particular cells, to create new cells and insert them into the notebook, and to destroy cells as well. As well as that, we wanted to change not just the sort of client-side notebook structure, but also the server-side state as well. So these are variables and setting variables here. These will be interacting with the kernel on the server, whereas these cells here are more interacting with the view of the notebook on the client side. And then some other metadata as well about the notebook source and so on. Okay, so my student toiled away for 4 or 5 months and decided, quite rightly I think, that he needed to keep server-side an in-memory data structure that reflects the notebook state. And this is really what we identified as the reified state of the notebook. This didn't and doesn't exist in Jupyter at present, apart from our version. You know, once the JSON file is served to the client, there's no way that you can then interact with that directly in the vanilla Jupyter system. So we've now got a data structure that describes the notebook and that you can interact with to modify the notebook structure. And that's kept consistent client side and server side. So the way to do this kind of thing is to register callbacks. In Jupyter, every event has callback handlers, and you can register particular callbacks to update the in-memory data structure when cells are executed, when state changes and so on. And there's a big long list of callbacks available here. We hooked into quite a few of them. Right. So I'm now going to stop sharing my PowerPoint, if I can work out how to do that. There we go. And instead share a notebook with you. Let's see if I can find one here. Yes, here I think. Good. So this is running on Binder Hub. Hopefully it should work. Right, so there's the student there, Charles. He's doing lots of exams at the moment, poor fellow. Right, so you could actually do this yourself because the library is available on the Python package index. You can just pip install Jupyter Notebook Reflection and hopefully it should work. Right, so I'm going to import his library, and this is the reified notebook here. My_NB is now a variable that points to this Jupyter Notebook data structure. Okay, so what we're doing here, we can get a cell from my_NB, and we're going to get cell 0, which should be, they're in order, the first cell in the notebook, which is this markdown cell. Oh no, it's a code cell. There we go, this code cell here. Come back to this cell later, it says. Okay, so, oh, I've lost where I am now. Get cell, here I am, get cell. So I'm going to get cell 0 and I'm going to print it. Run. Okay, good. So I've got a cell object. Okay, and the cell object is a code object and it's got some content in it. Great. Okay, and then I can just extract the content. Okay, so these are the outputs of my executions here. Great, so let's make a new cell now. Let's programmatically modify our notebook. So I'm going to make a cell, which is a code cell. Oh dear, you can tell this is a Python program with this student because he makes everything strings, which is horrible, isn't it? We shouldn't really be doing this, but never mind. Here's a code cell, and this code cell is going to print hello world, and This is just creating a cell. It's not actually attaching it to the notebook. So we've made a cell. Okay, and now we're going to clone this cell and set it to be the 0th cell in our notebook. So we'll just go, I'm not executing this yet. I'll go back to the start of the notebook. So look, we've still got this code cell here, which says come back to this cell later. And now I'm going to scroll down. Hopefully I'm not making you all seasick. I'm going to scroll down to here and I'm going to execute this one here. So I'm going to run my cell, run. I don't see any output, but if I go back to the start of my notebook, yay, look, print hello world. And it's actually executed it as well. So it's changed the cell to be the new one we instantiated, and then it's actually executed that cell after inserting it. And the reason why it executed it, I think, is because there's a default parameter here which says execute it, and you can actually set it to be false, in which case it doesn't execute it. That's what this next one demonstrates here. Pass a Boolean to tell it if you want the cell to be executed or not. So here we're making a new cell and we're updating the notebook. We're not going to execute it. So let's run that, run, and then we'll go back up to the top. Yep, so look, we've got the new cell code, but we didn't execute it. So it still has the output from the previous execution. Let's execute it now, interactively, not programmatically, just interactive execution. And there we go, we've got our goodbye world. Great. Okay, so what's happening is here that we are executing stuff server-side and updating our server-side reified representation of the notebook. But as we do that, we're also updating the client-side view of that notebook directly with these JavaScript callbacks. What should we do now? Oh, so let's change the type of the 0th cell. So instead of being code, it becomes markdown, which is documentation. Okay, so we can just change the cell type without necessarily changing its contents. So at the moment it says print goodbye world as, and that's code. So it's syntax highlighted as code. Let's change it to markdown. Oh, look, it's become a markdown cell now. There it is there, markdown. So there's no syntax highlighting anymore. Yes, and then we can also change the content and so on. And what we're doing here, setting the cell type back to code, but not executing it, and changing its content, but not executing it, and so on. Okay, we can insert new cells. So rather than destructively updating a cell, we can insert a new cell. This would insert it before the previous one. Let's run that. And there we go. Well, now we've got, oh, I think I clicked it twice, 2 print hello worlds before our markdown goodbye world, and so on. Yes, so we can do other things to update the cell. We can append to existing cells. We can delete cells. So let's, what's this going to do? Throw away the first 2 cells in my notebook. Let me just do that. Run. Then we go back up to the top, and those 2 hello world cells have disappeared, and so on. So these direct programmatic changes to the structure of the notebook are very nice. We can also query the state of the notebook, and this is the server-side kernel state, so we can see which variables are defined, and it will tell us what variables we've got and what their current state is, and their types as well, perhaps, yes. And then we can, now this is very exciting, we can set variables programmatically. So look here, content is a string saying hash come back to this cell later, and now I'm going to change the content variable so it becomes something else. Bar. Okay, and then I'm going to just evaluate it. There we go. So now I've actually programmatically changed this server-side variable to have new state. And it can be something else as well. So here it's becomes a lambda, and we've evaluated it with an argument and so on. And we can get the file name, and we can get the file path, and so on. And we can see how many cells there are in our notebook. Great. And we can get hold of the source code and perhaps change the source code of the notebook. And that's it, I think. Good. So let me just.
I have a question, Jeremy, with my hacker hat on.
Oh yeah.
So if I write a reflective piece of code that creates a new notebook cell which is evaluated, and that cell itself creates a new node, and then we get into an infinite loop. Is that bad for the Jupyter server, or is it just bad for the client side? Is this
okay? So
who's this an attack on?
Okay, yeah, I think it will be a denial of service attack on both the client and the server. On the server, because it will continue to create these callback messages and continue to update a data structure, which will become infinitely kind of looping. And on the client side, because your web browser is going to go crazy rendering this stuff, I think. Should we try and do this quickly? I wonder if we could. The only thing is, I wonder if it does evaluate it each time directly.
Because the first thing you showed me, you showed us that by default it was evaluating the new cell. Right? So.
Yes. Okay. So I wonder if this will work. Let's try this. Let's try this quickly. So if I make a new cell here, well, let me start up here. Let me make a new cell. Okay. So I want to say something like my_NB. It's always very dangerous to do live coding, isn't it? It might go horribly wrong. Dot. What do I want to say? Do I want to add a cell maybe? Make cell maybe. Make cell. And then I want to add it. So I want to make a cell which is going to be code. But the code itself is going to be mynb.makeCell, is that right?
Yeah.
Or do I need to do this thing with, I don't know, make cell?
Can you just refer to the content of this cell?
Right. Yes. Okay. Yeah.
I mean,
what you're saying now. Yeah. So if I say, oh, but I still have to give it a name, don't I? So can I refer to... Yeah, and if I say here new cell dot, is it get content? I need to check my own API here. Right, and then I need to add it to the notebook and execute it. But do I do that in the same step? I'm going to have to think about this one and get back to you. Sorry.
No, that's fine. Yeah, I don't want to derail you. Just a thought.
It's a very nice thought. Thank you. Yeah, I'm gonna think about that one and get back to you. Yes, good. Let me scribble that down. Something to think about. So recursive cell creation and execution.
Yeah.
Do I get into an infinite loop with a denial of service attack? Yeah. Thank you. That's a nice twisted question. Very good.
Sorry, my 16-year-old self coming out there.
Yeah.
How can I break it?
I think it's true to say that on most of these Jupyter servers, they do have some kind of load balancing and timeout behavior. So if you do get into these kind of infinite loops, then you can sort of kill things. I don't know if that would work for this particular case, but it certainly works for things like infinite loops and so on. That novices write, you can do timeouts and so on. Okay, so if you want to try this out, go to bit.ly/Jupyter-reflection and have a little play with it, perhaps. Okay, so this is my concluding slide now. I hope I'm not out of time. Very quickly, is reflection useful for notebook programmers? So I'm going to argue yes, because there's a number of potential use cases and GitHub tickets for reflection requests. What should a reflective API for Jupyter actually be able to do? And I've given some suggestions here of possible features, but I think there are others as well, and your feedback is welcome. And I think that's the end of my talk. Yes, it is. Good. Thanks very much.
Great, thank you very much. So, more questions or other ways to break the system?
Yes.
Dominic's denial of service looks quite interesting, because it seems to me, in terms of old-fashioned, I have an editor with some source code and I have a system that's running the code. Not only is it running the code gone into an infinite loop or whatever, it's about to crash the machine, but the only way I've got to correct it is by interacting with that same system to remove the errors from the code, but I can't do that either. You seem to be fairly well stuffed.
Yes. So you do what any sensible browser user would do and just close your tab and reload the page. Of course, if the thing had persisted, because it does do auto-saving, doesn't it? Then
yeah, but
you'd still be stuck. Yeah.
You effectively reload the same page, but just a few more iterations down the line, but it's still going.
Yeah, I think when you reload the page after shutting the tab, you'd get the last version that you'd saved, and if you hadn't clicked to execute anything, then the thing would be in a sort of a steady state. It wouldn't be doing anything, and then you could go and fix your mistake if that had persisted.
So it would stop running.
Yes, I think once you close the tab, that will time out and your reload will load a non-executing page.
Because when you reload, you go back to a completely unevaluated state, right? You have to go back through and evaluate things.
Yes, that's right.
But it might do something bad to the server, and it might, I don't know.
I think it might do, yes. I'm going to have a little play with that. Thanks for that lovely suggestion.
Welcome.
I mean, I think we are giving the developer more rope with which to hang themselves. Yeah, I can see lots of hands. Do I want to pick people, Olaf, or are you?
Yeah, feel free, yeah.
Okay. Hello, Stefan.
Yeah, the things that I'm missing from the whole notebook experience is kind of the classic software engineering bits. So when you told us metaprogramming, one of the things I would have imagined is, okay, let me turn a cell into a function that I can then use and use the reusable building block or something. So my specific use case is I built that system for my benchmarking, which is essentially kind of a notebook over a database, and I load the revisions, the performance results for the different revisions. But sometimes I want to compare extra stuff in there. So I essentially want a loop and kind of pick out the bits I want to compare, but essentially run the same code, but over a different axis. And that's super annoying. And in the end, I use useKnitter or R Markdown, which is pretty similar, but it's a plain old text file with some blocks of R in the middle. So it's slightly different to the Jupyter in that it doesn't have the extra metadata, but it runs nicely as a report generating thing. But I had to move away because I couldn't do the fancy things I wanted to do. So yeah, kind of being able to grab a block maybe as a function would, I think, be really, really useful.
I think you make a really valid point there, a really useful point. Jupyter doesn't have a good story on modularity. Oh, hello. I can see a young member of the programming community there. Good. I think it's true to say that notebook cells are entirely orthogonal to a kind of functional structure of your program, or even an object-oriented structure of your program. And yeah, You know, code reuse in notebooks isn't easy as well. In ordinary Python, you just say, you know, import such and such a thing, and you get it. But it's difficult kind of importing notebooks and encapsulating notebooks in a sensible way. Yeah.
I had a sort of quick comment on this, which is why I unmuted this one. I found a beautiful notebook that really shows just this thing that you were talking about, which is some Financial Times data analysis. And it's just very clear that what they do is they want to do the analysis of waste on plastic and paper. And their abstraction mechanism is at the beginning of a notebook, they define a variable waste type equals plastic, comment paper. And the way to run this twice is you just uncomment and then run it again. And that you can totally see why they do it, because then they get all these intermediate results. So I think this is like, that's my favorite abstraction mechanism, and it's so much better than functions.
Is it? I mean,
it is, because you see all these intermediate steps, and it's like, it's so much nicer than functions. With functions, you just get the result, but you don't see what's inside.
Well, I mean, I do the same thing, right? So I typically have my notebook code, and I do need to build functions because things are getting more complicated. But so because you can't easily evaluate those, so the thing I do is I have in comments essentially the assignments of the parameters, and then I evaluate the chunks of the blocks to kind of debug those. And it's as a programming language person, it's all very not satisfying. But you want that REPL like, and you want the plots and everything right there. But
you're missing unabstraction. You need to do, you know, the thing that Alonzo Church forgot to add in the Lambda calculus, which was really the opposite of abstraction. You need to unabstract to open the scope of your function.
Yeah.
Right? If you sort of analyzed all these things that people really do and can't quite do, then I think that gives you a beautiful list of things that your system could sort of nicely implement.
Thanks. Hello, Stephen. You've got your hand up, virtually speaking. Oh, and your hand up really as well. Yes, hello.
Hi, Jeremy. Thanks for that. I'm just, I think my comment is related to what we were just talking about, actually, because when you do reflection, you sort of have a choice. You can reflect from the inside or from the outside. And I was wondering whether, because it feels like with the DOM and with JSON and all these other technologies, they're actually quite suited to getting your fingers into the notebook from the outside. And may have people done that? Maybe things like browser extensions or just tools that will mess with the notebook contents. I don't know. If it'd be interesting to understand whether or why not.
Right. Okay. So I'm trying to think this through. What you're saying is the browser side rendering of the notebook is itself an HTML document, and you're saying, could we interact programmatically with the notebook through the DOM? Right.
Yeah, or some other. It might not be that the DOM is right, because like you said, the client server side of it, it's like the substance of the notebook is somewhat hidden behind this interface.
Yes, that's right. Although you can, if you know the right JavaScript calls, you can sort of hook through to the server from the client. Yeah. So I think that would be possible. You'd have to wrap it up very nicely for novice programmers, but yeah, I think that could be done. I think it would be perhaps a more complex way of doing it. You're right. We're reflecting from the inside, and I don't do it from an external perspective. Yeah. Okay. Thanks. That's a good alternative.
I've written a notebook system that sort of kept all the state on the client, and then you could sort of add JavaScript cells to it where it would just expose the state as a variable for you to do whatever you want with it. And that sort of lets you do reflection, but it really relied on actually having the state somewhere, where in like normal Jupyter, it's sort of, it's even hard to say what the state is and where it lives.
Yes, yes, I think that's something we struggled with. Thank you. I can see one more yellow hand. Benjamin, hello.
Hi, Dominic's point previously on trying to throw a denial of service attack onto Jupyter by inserting the same cell over and over again. I was curious, and I had a quick go. And interestingly, I've managed to get a one-liner that sometimes works and sometimes doesn't. It tries to keep inserting itself. It tries to keep inserting the first cell in the notebook.
Yeah.
Sometimes when you run, it immediately adds 150 and then keeps scrolling, and then I just close the tab because I don't want my web browser to crash.
Yeah.
And sometimes it doesn't seem to do anything.
Oh dear.
Which
so
is interesting.
Can you paste your code into our little comment? Have we got a comment section here or something maybe?
I can't seem to. I mean, it doesn't look very nice, but here you go.
Okay.
Yeah. All you have to do is get cell 0, insert a deep copy, and it worked. I was quite surprised. But it's also not perfect for some reason. I'm not sure why. Sometimes it just replaces it with a different number on the left, in 37 to in 38, and sometimes it spams the whole screen.
So we have non-deterministic behavior. Fantastic. Yeah.
I thought you might like to know.
It's a bit worrying, that, isn't it? Right. I shall look into it. Thank you very much.
Thank you for the talk, Jeremy.
Cheers.
Yeah, are there any other questions? Dominic is running away. Doesn't look like any questions are coming up right now. So I think, yeah, this did.
So maybe just one more. What were the specific problems around the different languages?
Yeah, so we stuck to Python in the end, but really it would be nice to have a kind of language neutral system that would allow us to interact with, say, the Haskell kernel or the Julia kernel or whatever. So our Python system in places has to construct strings which get sent to the JavaScript interpreter and then has to parse what comes back from the JavaScript interpreter as well. So we've got those two languages there which sort of do interact with each other, but we weren't brave enough to try and consider other language kernels on the server side.
Yeah. Any other comments, questions? Everyone keeps quiet. So I think first of all, thank you very much again, Jeremy, for your talk.
Thanks, everybody. Lovely to see you all. And thanks for your feedback as well. Much appreciated.
Yeah, it would be great just to go now down to the Gulbenkian and have a drink. But
oh, yes.
I fear everyone has to have a drink on their own if they want to. Yeah, some point I'm sure you can come down and visit us again. Yeah. Wow.
Good to see you, Jeremy.
Thanks, Richard. Thanks, everyone. Cheers.
Yeah, thank you very much. Yeah, so next week, David will tell us a bit about his work because he joined us just a few months ago. And so we will learn more about what his interests are. But also, I just want to remind everyone that there's still lots of free slots in our schedule. So if anyone is keen to give a talk. I mean, I know that in the next few weeks, everyone is just thinking about marking and Viva, so it's hard to fit any time in between there. That's the difficulty. But yeah, if you do, or if you know someone, you know, you can push to give a talk, then do so. Yeah.
Our PhD students are not marking, are they?
No, yeah, so let's see.
Benjamin looks like he feels.
Don't look at me.
Yeah. So I don't want to look at anyone in particular, but yeah, maybe PhD supervisors want to consider this option. Yeah, have a chat there. But yeah, otherwise, yeah. So thank you very much, Jeremy. I mean, I hope the recording will be, well, first of all for the PLAS group, but at some point also on YouTube, then everyone can enjoy it again. Well, thank you, and see everyone else next week. And Jeremy, hopefully see you again sometime soon again as well. Bye-bye.